I hope you don't mind me answering in such detail, but we've a few of us and we got a lot of time, so it's really, I like going into detail because when you give a short answer on the top, it's less trouble for you to deal with that, but you don't learn as much as if you kind of learn, have to go through some of the logical trails that get you there.
That was perfect.
Yeah.
Do it
Good.
again.
Yeah.
What was that you said?
Go ahead.
Well, being that we're still talking about the experiment, I was just wondering if it was possible that you, to me, how you came to the theory. I mean, as far as your observations of what experiences or experiments you've done in the past that led you to believe that we are in a virtual reality.
Okay, that's a good question. How did I get there? Well, I started out wanting to understand consciousness. I had some interesting things happen in terms of consciousness when I was 5, 6, 7 years old. Then as a graduate student, I had an unusual thing where I could debug code in my mind in consciousness space much faster and more accurately than I could if I actually was doing it, physically. So with those strange occurrences, particularly the last one, I changed my attitude about the nature of reality. When I was earlier in graduate school, before I had that experience of being able to find bugs in code, I had the same kind of attitude that almost every scientist has, and that is, it's called I forget the name now, I'll get it in a moment, but it says that things are real, things are part of our reality, only if you can measure them. If you can't measure them, then either they're not real or they don't matter. Because if you can't measure it, you can't interact with it. If you can't interact with it, then it's either just something in your imagination, you can't physically interact with it, or it's irrelevant, it doesn't mean anything. So the only things that hold meaning are the things that can be measured. If you can't measure it, it's off the map as far as science goes. It's not a part of our objective reality, because objective means that you can measure it, you can interact with it. Okay, that's the basic scientific determining how you determine what's real and what's not real. Can it be measured? Can you interact with it physically? Well, when you can debug code with your mind, how are you doing that? How does that happen? I'm not doing it logically. I'm not actually looking at the code line for line and looking for errors, just like I would be if I were physically looking at the printout. I wasn't doing that at all. I was letting the code just kind of flow through, and lines would show up red, and then I'd back up and look at the red line. It wasn't the same process at all. It was a totally different process taking place. And that showed me that reality was more than just what you could measure. Because though I could take some measurements of it, I could measure the fact that the information I got was, in fact, real. Those were the lines of code that were problematic. So it actually worked. So I knew that it was a real thing. It wasn't just my imagination dreaming up random lines of code and thinking that those were the errors. They really were the errors. And I could find all the errors that way. So I knew something was going on that wasn't measurable. It was just in mental space. You can't take you can't take your ruler with you in mental space. You can't measure things in mental space. So then, as a physicist, I looked at that and said, well, it looks like that I have limited myself to this reality, when reality is actually much bigger than that. I've only been looking at this piece, the piece that you could measure, but there's so much more to it. So once I had that idea, I started looking for more evidence and more understanding and more, how does this other part work? And how do you define it? So that's where I was. I was in that space when I ran into Bob Monroe. So when he said, you want to work, I'm looking for people to work in my lab, with consciousness, I was immediately, yes, terrific. I'd love to do that, because I was sitting here with this question of, what physics does is models reality. That's what physicists do. They model reality. They mostly model it with mathematics. And I've only been modeling this one little piece. Reality was so much bigger than that. And as a scientist, I wanted to explore what the rest of that was and explore it in a way that it was logical. How does it work? Why does it work? Just like you do with this piece that you can measure. How does it work? Why does it work? If you do this, then what'll happen, and what's its logic? Because I knew there was logic to this bigger piece. I just didn't know what it was. So then that was my mission through the years that I was working with Bob Monroe, was to come up with that idea of how does it work. So first, I just wanted to understand consciousness, because consciousness was the seat of this bigger reality. I was using my consciousness, my intuitive side, to get these answers. It was intuition. Intuition is a real thing. It just doesn't, we just don't know what the rules are. So it seems haphazard, and you can't depend on it because we don't understand the rules. But it's a real thing, because my intuition was debugging code. So that was my approach. My approach was just to discover more about this thing called consciousness and the intuitive process. And that's what I worked on. And that's basically was the book I published. The first book I published in 2003, February 2003, was a model of consciousness. Somewhere like 2005 or 6, I got an aha moment that said, these very same principles explain physics. Wow, I'm a physicist. I should have seen that earlier, but I didn't, because I didn't really have this understanding that these two worlds were all connected. I had this physical reality, and that works, and I had this other reality that was bigger, but they were kind of separate in my mind. They weren't all part of the same thing. So I really wasn't looking for physics in the model of consciousness. So I missed it. It wasn't until later that I got the aha moment that, gee, the same way the consciousness world works explains quantum mechanics. Because the conscious world works on probability. Everything is just potential, and it's just probability of existing. And this idea that you take random draws from the probability distribution of the possibilities, and that's how things come into the reality, and that just fit quantum mechanics perfectly. But I didn't see that for a while. And as soon as that fell out, I said, well, gee, if I can derive quantum mechanics from consciousness, what about relativity? What's the big deal there? The big secret there is, why is speed of light a constant? You see, speed of light is the only thing that's constant. Everything else, velocities add. They're not just constant no matter what. Okay, the example I usually use, if you are in a car going 10 miles an hour, and you have a ball in your hand which you can throw 10 miles an hour, and you put your hand out the window and throw the ball in this direction that the car's going, the speed of that ball relative to the ground is the 10 miles an hour you get from the car plus the 10 miles an hour you got from your throw, and the ball's going 20 miles an hour relative to the ground. Velocities are additive. So if you have a platform moving, velocities inside that, they're relative. That was relativity. Right? Well, the thing that made relativity work is that C doesn't work like that. It's a constant. So you have a flashlight traveling, 9/10 or half the speed of light this way and you turn the flashlight on, it's not that the light comes out this end, the speed of light plus half the speed of light that the flashlight's going, it just comes out at the speed of light. Why? Why don't they add? Everywhere else they add. So that was the big mystery in quantum mechanics, and that's how Einstein first published his first work on relativity. Didn't include gravity, it was called special relativity. And just based on that one fact, that the speed of light's a constant, and nobody expected that to be true, but just he came to that conclusion based on his own thinking in his own head and said, well, what if the velocity of light is a constant, always, under any circumstance? And because of that, he did a little algebra, and out came special relativity with some amazing things. The amazing things were that as a particle traveled faster and faster, its dimension in the direction that it is traveling gets shorter and shorter. So if you have something that we measure here as a yard long, and you travel in the direction of motion, that thing gets smaller and smaller and smaller and smaller until you get to the speed of light and it disappears altogether. That was a singularity. In other words, the equations don't really tell you what happens at the speed of light. You get to a point where the equations don't work anymore because you're dividing by zero. And that thing, and if it weighed a pound, the faster and faster and faster it goes, the heavier it gets, the more and more mass it gets. Till you get just to the speed of light, and then the mass is infinite, just as it also disappears. The singularity where the equations break down. So those are called, well, I'll do the last one. The other one is that if you have something that travels very, very fast, time slows down. And that's why things are relative. So if you're going very, very fast, you're going 9/10 the speed of light, and you have your watch and your calendar, and you see that a year's gone by. Well, a year's gone by for you, but back from where you started out, maybe 10 years have gone by. So there's a thing called the twin paradox. Two twins. Put one of them on a rocket ship, it goes 90% the speed of light this way, you know, and comes around and lands, and that twin that was in the spaceship is much younger than the twin that stayed home. And if you go far enough, long enough, at high enough speed, the difference can be massive. One can be 110 years old and the other's still a teenager, you see. So obvious differences. And everybody thought Einstein was ridiculous because all of those things were just stupid. The world couldn't work that way. It didn't make any sense. But then we got satellites that travel around the Earth very quickly. And we put cesium clocks on the satellite. Cesium clock is it measures cycles, you know, vibrations in the cesium atom, which are very, very fast. Therefore, you can measure very accurate time. And there's something that counts those vibrations. So that makes a cesium clock. That's what this is, basically. It's the same thing. Digital clocks are just little atoms in there that vibrate, that create time, but very, very accurate time because they vibrated at such a high rate. So they put a cesium, got a piece of cesium and cut it into two pieces and put one piece that goes up with the satellite and another piece that stays here, and they send it up and it spins around the Earth at a pretty fast speed. And then when it jettisoned its little package back, they got it, and one of the clocks had a higher count than the other. Time dilation. Einstein was right. Wow, surprised everyone. And then they did the same thing with the length contraction, with the mass, and a cyclotron. They send these things around with magnets. They have charged particles, and the magnets push them. The next magnet pushes it a little more, and they accelerate it, okay, called a cyclotron. And they spin them around and around, and they find out that the faster they go, the heavier they get. They have to put, you know, they don't get the same push on them. It takes more force now to accelerate them more because they're actually heavier than they were Einstein was right again. And the same with the length contraction. So all of those weird things were actually measured, and they do happen. And Einstein was right, right again, and then right again. So his status went from a crazy guy who obviously was demented to a genius who figured out things that nobody else figured out. And he did it with an assumption that light was constant speed. So that was the big secret. Nobody knew why it should be that way. I mean, what kind of universe is this where things get heavier and shorter and you know, time goes by more slowly based on how fast you go? Well, Einstein realized that it really wasn't just space and then time, but time and space were mixed together. He called it space-time. It's a thing that the times can interact with space and the space can interact with time. So that was our four-dimensional reality now. It was 3 in space and 1 in time. And that's the way scientists look at our world now in terms of space-time. Well, then he went to general relativity, which takes that idea and tries to explain gravity. And basically Einstein just came up with a geometric model of gravity. And that is, the reason there's gravity is that space-time is like a fabric and it's not flat. It's not smooth. And then you think of space-time as like a fabric that as you have more mass, the mass is like, let's say a trampoline. And if you put a heavy bowling ball on a trampoline, then the trampoline sags under the ball. Well, gravity is because other particles come, they roll downhill because of that sag. So gravity now was basically wells, you know, deep spots in the fabric, in the space-time fabric, that as mass got together, well, then there'd be these two wells and they'd come together. Whereas before, we had a simple idea of gravity is that masses attract. All masses attract. And there's some constant of proportionality that says you take this constant, multiplies it times mass 1 times mass 2, divide by the square of the distance between their centers, and that's the force at which all mass attracts. So there's two different models of the same thing. One's a geometric model, the other is a model that just has an assumption mass attracts. Why do they attract? Nobody had any idea. But they just do. Because you have to come up with that equation like Kepler did so that you can see that all these things orbit. You know, we're orbiting around the sun. And all that requires what's called a radial force, which meant that gravity was there, which meant that they had to attract. But we didn't know why. We still don't know why. Einstein just had a different metaphor. Instead of the masses attract, he had the space-time is curved. There's still no answer as to why any of that would work. It just is another way of modeling it. And Einstein's way turned out to be a little more general, so it could come to more conclusions than it could if you just had masses attract. But it's still just another model without a understanding of why it works. Well, in my theory, because this is a virtual reality based on a rule set, it's easy to say gravity is just one of the rules. It's an equation. It's required in order for the simulation to develop. Right? To make a simulation of a world, then you can't just have everything just blowing apart. It doesn't turn into anything. You got to have something that pulls it together and starts forming things that can evolve and become something. So if you're making a model, one of your equations is this stuff's going to have to stick together somehow. So what is gravity? It's an equation in a rule set. It's just very simple. It's part of the rule set. It has to be there, or you'd never get the virtual reality to evolve into something stable enough to be useful. So you put it in there because that's what's needed to make a useful virtual reality. So anyway, I've wandered all over the place on that one. So I guess I started out with how did I end up with this? Well, I started with consciousness, got to where I understood consciousness, and that was just me exploring. You know, I learned in consciousness to do things. I could use my intuition to get information. I did it enough where the information I could verify was right, that I had confidence that it was real. And I did this in a whole lot of things, and I knew that it was real, that the information was accurate, just like being able to debug code. And I wanted to know what variables changed what. So it was a matter of just doing research. Hold these variables constant, change that variable, and see how it changed the effect. Didn't change the effect at all, well, that variable wasn't a player. If it did change the effect, then how did it change the effect? Was it more of it would make the effect better or worse, or was it the approach? Was it the order of things? So, you know, that's why it takes so long. There's a trial and error, just moving variables around, setting up constraints, doing it again, doing it again, doing it again, until you eventually get an idea of a set of facts in the world of consciousness. So about 30, 35 years, I'm trying to develop a set of facts that describe consciousness. This is how consciousness works, and here's all these facts I've come up with that I'm able to measure in the sense of my own manipulation of them and their consistency, and do they work? And if they're not consistent, why is that? Is that because I'm not consistent, or because there's just no consistency out there? So I have to work with myself as part of that. It has to do with me and how I feel and where my head is and so on, which is why I stopped eating sugar and stopped, you know, drinking alcohol, to get all those other variables out of the mix, because otherwise I wouldn't be able to tell what was doing what to what. So I cleaned up my diet just so I would be clear-headed and not have other influences working on my mind. So anything that would affect my mind in any way, I tried to eliminate so that I would have clarity. So when I was done, I wrote this book called My Big Toe, and it was a theory of consciousness, and it basically outlined a bunch of the facts of consciousness, which turned out to be things like entropy, you know, the virtual reality, all of those concepts developed. I probably was 25, 30 years in before I got the idea of digital, virtual reality. And then bam, that just, you know, oh, that tied this, and this fact all together. And it started, the puzzle pieces all started together and stick together, making a picture. That was a big step forward, to see it as information and as digital. And then a lot of the pieces came together and the facts started to all connect to each other. So that's how I ended up with the virtual reality. That's the last chapter about Sam's virtual reality emporium. There was talking about that idea in book 3. So I got that far in consciousness and I had this whole bunch of facts. And I had some way of interrelating them to each other based on my consciousness model. I'm a physicist. I got a physical world with a whole bunch of facts and how those things relate to each other. So now my job was to bridge those two and say how to, you know, they're not separate. Obviously, they're not two separate worlds. That was not right. I could use my intuition to work in the physical world. They're connected somehow. So how do I connect these? And because I was thinking in those terms, how do I connect these two? I know they're connected. I know the physics is a subset of the master set. I know from the facts that I found in consciousness, I know that consciousness is the superset. It's the source. And everything else is derived from the source. So, like I say, a couple of years after writing the books, I got the aha connection of how that would work, and made the connection then into quantum mechanics and then into relativity. And it found I could answer these big mysteries that were in physics from my understanding of consciousness. So then I looked for all the other big mysteries, you know, and they just all fell apart. Each one, you know, just fell out. I could understand them from the viewpoint of consciousness. And all that happened probably, I don't know, 10 years ago, or so. It wasn't that long. It was, like I say, 3 years, maybe 4 years after I published. So then I could get this set of facts and that set of facts and bridge them. So it was all one thing. I knew it had to be, but I didn't know really the mechanism until about a decade ago. I started putting it together. So then I started searching for mysteries in physics and other things. And every one of them just was easily explained from this viewpoint of consciousness and virtual reality. There were lots of them. Physics is just riddled with things that physicists don't understand. Gravity is one of them. But there's lots of things that they don't understand, and this gave the answer for those things. So that's how I ended up with the model. And then after thinking about the physics, I started to think about, well, could I come up with some experiments that helped demonstrate the connection between the consciousness and the physics experiments, which is then why I ended up with these experiments. So that's a very long answer to a simple question about how did I get there from here. But that was basically the process. And now all of those mysteries I could come up with are all solved. Even the mystery of chaos theory. Chaos theory was a big thing that happened I guess it really started to happen in the 70s. Got big in the 80s and 90s as a whole new way of looking at reality, and then kind of dribbled off into obscurity after that. Wasn't nearly as big a deal, although it's still around. It never made much press, so a lot of people aren't as familiar with that as they are with relativity. It's not as sexy as relativity. It doesn't do cool things like relativity and quantum mechanics do. But anyway, there's a big mystery there. How does that work? Why does it work that way? Well, it turns out that it's a direct consequence of this idea that reality is drawn randomly from the probability distribution of the possibilities. That's what creates. That's why chaos theory works. That's the fundamental root of it. So it does answer all the mail. So it's an evolution. I spent years doing this. When I was at Monroe, I was in my 20s. I was probably 24 when I first started going out there, middle 20s, and now I'm middle 70s. And it was only 10 years ago that I really put a lot of the picture together. So you see, it all evolves. It takes a while because this is something that, as best I can tell, has never been thought of before. So you're breaking new ground. When you go into these things, it's like these are thoughts that you can't just take a lot of things that already exist and stick them together. You really are breaking new thought patterns, new ways of looking at things. And that's slow. That doesn't happen quickly. That's something that happens slowly, and you get an idea and then you have to verify it, so you get more ideas and you have to test it, and it goes on and on. So my evolution on these ideas is still continuing. I'm still figuring things out, still coming to conclusions. But so far it seemed to work pretty well. So my big toe now is a theory of consciousness that's also a theory of physics. And if these experiments work the way I think they will completely change how we think of reality. They'll completely tear up the foundation underneath physics, and it'll have to be redone. That will change everything else. That will also tear up the foundations of biology, of chemistry, of all the hard sciences, and actually all the soft sciences as well. Psychology, sociology, everything will have to change at the root, at the foundation. It doesn't mean that the things that these sciences and soft sciences have discovered are wrong. It just means that they flow from a different set of logic. It's just a bigger picture logic. instead of having you have this little picture and it's does its thing, and you have another little picture over here and it does its thing, and you have quantum mechanics over here and it can do its thing, and then you have relativity down here, but none of them are connected to each other. They're all a bunch of separate little things where you've figured out a bunch of facts in a small space. And that's what we have now, and this puts them all together. Now they're all connected. There's one or two simple principles about the nature of reality and the fact that reality is virtual, and then they explain everything else. So you can see how all the separate chunks are all connected, which is new. And it'll change the nature of the way we see science dramatically. And usually when you have a big paradigm shift in science, you also have new gadgets and niftier ideas and things, that make life easier and better for everybody. It tends to also generate a lot of applications. Here they won't be necessarily a lot of applications in stuff, but there'll be a lot of applications to your life, to your way of thinking, to your way of being. And some of it will be also to new stuff, new ways of doing things, but a lot of it will be on the soft side, which is good because that's where we're behind. Our hard side science is way up here. Our soft side science, which is how we work and how we think and how we make decisions, it's way down here. It hasn't nearly risen and grown as much as the hard side of science. So we really need to catch up a bit, because if the hard science gets too far out ahead, then we end up shooting ourselves in the foot and making very poor decisions because we don't have the capacity to understand the consequences of what we're doing with the science and with the technology. So that ends up being self-destructive if there's not balance between the hard side and the soft side of us. So that's important. Well, I see we're not going to run out of questions if I take an hour to answer every question. But go ahead.
It's a real long weekend.
Yeah.